Hello everyone, this is a worked out solution to number 49 from homework 4. This is a type of question that will most likely appear on the test tomorrow. So let's take a look at it. So it says, an archer shoots an arrow at 30 degrees above the horizontal. The velocity is 49 meters per second. Okay, so the first thing that we want to do is we want to draw a picture. So let's draw a picture. We have a velocity here of 49 meters per second. Okay? And the question asks us to we want to find the maximum height, so I'm going to call that dy, and the time, and also dx, the maximum range. So this right here is dy, and this right here is dx. Okay? So the next thing that we want to do is break up this vector into its x and y components. Remember that with these problems, we're trying to split them up into two separate problems. One in the y axis and one in the x-axis. But in order to do that, we need to break up our component of 49 meters per second. So in order to do that, we need to call in our friend SOHCAHTOA. And we're going to call this V initial, okay? So V initial in the y direction is going to be V initial sine theta, okay? And then V initial in the x direction is going to equal V initial times the cosine of theta. V initial times the cosine of theta. So quickly, if we just work these out, so it's going to be 24.5 meters per second, and that's going to be 42.4 meters per second. And we'll box that in too, just so we know where to look. We want to find our dy. So let's work on finding dy here. Find dy. Okay? And the first thing that we want to do is we want to list all of our known y components. Okay? So obviously our first one over here, we have an initial velocity in the y direction of 24.5 meters per second. Okay? And remember, in this problem, just in the y direction, this is just a problem where the ball is going straight up, or I guess the arrow is going straight up and then it's going straight down. So if we're looking at this instant right at the top here, we can say that we have a v final in the y direction of 0 meters per second. Okay? 0 meters per second. So we also know, we also know that g is equal to negative 9.8 meters per second squared. Remember that g only acts in the y direction. Okay? We are trying to find a distance, and we don't know a time. So we want to use the equation that doesn't have time in it. Okay, so if you look into your notes, you'll find that the equation that doesn't have time goes like this. V final squared is equal to V initial squared plus 2AD. Now we want to manipulate this equation for our variable here, d. We want to solve for d. So if we do that, you're going to get d is equal to v final squared minus v initial squared all over 2a. But now let's rewrite this for the y component that we're in, or the y direction that we're in. So we're going to get d in the y direction is equal to, oh, well, hey, you know what? Let's just cancel this out right now so we don't have to rewrite it. That goes to 0 because up here it's 0. Okay, right at the top of the arc. So we're going to get minus v initial y squared over 2 times g. If we just plug in the values here, we're going to get negative. We know v initial y is 24.5 meters per second over 2 times negative 9.8 meters per second squared. And that's going to give us, and we get, oh no, my mistake was that I just forgot to do a little squaring there. And if you end up plugging that in, you're actually going to get 30.6 meters. Sweet. So now we found dy. So dy is 30.6 meters. All right, let's move to a fresh page here. The next thing we want to find is the total time in the air. So we're going to use this information that we have over here still, but now we're going to use the equation. There's lots of different equations you can use, but let's use the equation that doesn't give us distance. So now we are trying to find time, but we're going to use the equation that doesn't give us distance. Even though we have it, we're going to just humor me, okay? And remember, the total time in the air is only governed by the motion in the y-axis. Okay, so that's why we're going to use these same variables over here. We have those variables, and we're going to use the equation v final is equal to v initial plus at. This is the simplest of them all, and I think it's good to use the simple one when you can. So let's rewrite this in our y direction. So we have v final in the y direction is v initial in the y direction plus g, because acceleration is gravity, times time. Now right away we remember that our final velocity goes to 0 because we're looking at the point right up there, right? When it goes up, 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 and then it pauses for an instant and then comes back down. So now let's solve this. So we're going to get something like negative v initial y equals gt, and then we're going to get t is equal to negative v initial y over g. So then t, if we just plug in the numbers here, remember our v initial y is 24.5, so we get negative 24.5 meters per second over a negative 9.8. Oh, sorry, meters per second squared. Always include your units. And we get, for a time, 2.5 seconds. 2.5 seconds. Okay? But remember that that's just the time for the ball to travel, or the arrow to travel up to the top of its arc. So if we want the whole arc, both up and down, we're going to have to multiply this by 2. So our total time is actually going to be 5 seconds. Okay? So our total time in the air, over here, that's actually 5 seconds. Beautiful. Okay, so now we can finally find this last question. What is the maximum range that this arrow is going to have? Now, we talked about it in class. The horizontal direction of the motion isn't going to be accelerating at all. Okay? So because it's not accelerating, we cannot use our kinematic equations on it. So, just like before, we're going to find, a little thunder out there, we're going to find dx, and we're going to write our known components, our known x variables. Sorry, this should say variables. So time isn't bound by x or y. So we know that we have a time of 5.0 seconds. We know we have an initial x velocity of 42.4 meters per second, and we want to find dx. Now, if you remember, we can't use the kinematic equations, but there is one equation that we can use, one of the very fundamental ones, and that goes like velocity is distance over time. So again, let's rewrite that in the x direction. So we get Vx initial is equal to dx over t, and we're solving for dx, so we get dx is v initial x times t. Now we can just plug in our values here. Dx is equal to, looks like we have 42.4 meters per second times 5 seconds, and that gives us a dx, a range of 212, well, I guess we can round it to 213 meters right there. And that's going to be our dx. We can come back over here. All right, dx is equal to 213 meters. And that is how you solve a projectile motion problem like this.